So far, we have learned how to find the sampling distribution of the sample mean, x bar. We learned in previous videos that to find the sampling distribution of the sample mean, we either require that the parent distribution be a normal distribution or the sample size we're drawing from a non-normal population be a large enough sample, that is a sample with units greater than 30. Now we proceed to the sampling distribution of the sample proportion. To motivate this example, let's consider this example. Or to motivate this concept, let us consider this example rather. A sample of 500 nursing applications included 60 from men. We are to find the sample proportion of men who applied to the program. A little backstory to this. If we're choosing a sample of 500 nursing applications, then there must have been a bigger pool. This bigger pool in statistics will be called the population or the entire population of all nursing applications. Out of this entire population, we drew randomly a sample of 500 nursing applications. Why did we draw that sample? It is so that we can observe how many out of these 500 nursing applications were from men. And we observed that 60 out of this 500 were from men. So as far as the sample is concerned, there is a sample fraction here. So in English, you will call it a sample fraction. In statistics, we will call it a sample proportion. That sample proportion, rather than writing the whole full English, we choose to write these symbols. We can either write P hat or even P bar. So I can use either of these to represent the proportion in the sample that have a certain attribute of interest. The attribute of interest in this consideration is out of 500 nursing applications, how many are from men? And there are 60, so that will give us 0.12. So take note, we can derive a formula from here for finding the sample proportion, which again can be represented by P with a hat or P with a bar on top. And that formula is out of the total sample size N, how many have a particular characteristic or attribute of interest. So if we had decided to go to the entire population and we can observe or examine all nursing applications in the entire population, there and there we would have had something called the population proportion, which is represented by capital P. And it will be out of the entire population size, which is represented by capital N, how many have the attribute of interest? And that will be capital X there. If we are unable to observe the entire population, we settle for a sample, just like it was done in this example, where from the entire pool of nursing applications, a sample of just 500 was drawn. That would lead us to a sample proportion, whose formula is given by P hat equals X out of the sample size, or out of the entire count of sample units. So, our interest in this topic will be the sample proportion. Does it have a sampling distribution? The answer to that question is yes. Primarily, the sampling distribution of the sample proportion has the binomial distribution that we learned, not a normal distribution. So the parent population is not normal. So it is not a normal population. But if we were to observe all the sample means that can be drawn from this binomial or non-normal population, it is possible that the sample mean can still follow the normal distribution with the mean mu and standard deviation, whose formulas will be given in the next on the next page. However, to use this normal distribution, there are conditions that have to be met. One, the samples must be simple random sample. The conditions for a binomial distribution must be met. And the sample size must be large enough to ensure that n times p is at least 10 and n times 1 minus p is also at least 10. In order to further encourage our understanding of this, let's go straight into some interesting details. First of all, what we have said so far is that as long as these two conditions are met, we can approximate the binomial sampling distribution of the sample proportions by the normal distribution. If we're going to use a normal distribution, we're going to need two settings. We're going to need the mean of the sample proportion, which we denote by mean of p at, and that is exactly always equal to the population proportion if it exists, and is equal to the sample proportion if the population proportion does not exist. I'll illustrate this in the examples to follow. Then it also has a formula for the standard error. Let us note this. When the p is not known, we can estimate it using the sample proportion. So suppose that the sample proportion was given to be 0.31, and we have a sample size of n equals 100. If we are to find the approximate binomial sampling distribution of the sampling proportions, there are two things we must do. First of all, step 1, we must check that these two conditions are met before we can use the normal distribution to approximate a binomial distribution. First, we'll check what n times p is. Our n in this question is 100, and our p, remember, since just p is not given in this question, when p is unknown, we can estimate it using p at. That means we can represent this p with this p at when the actual p is not known. This is equal to 31, which is greater than 10. So that checks out. Then we must also find what n times 1 minus p is. That will be 100 again, but this time 1 minus 0.31. This will be 100 times 0.69, and this is also 69. What do we find out? This 69 is also greater than 10. Since these two conditions are met, that is good news for us. So step 2 will be that we can find the normal sampling distribution parameters. The normal sampling distribution parameters as follows. We can find the mean of p at. This is going to be equal to p, and since p is not given, we estimate it using p at, which is 0.31, and the standard error of p at is the square root of p times 1 minus p divided by n. That will be the square root of 0.31 times 1 minus 0.31 is 0.69 divided by 100, and this will be equal to 0.04625. So the sampling distribution of p at, so p at has the normal distribution with a mean of 0.31 and a standard deviation of 0.04625. A similar process can be done for the second example. So if you may, you can read through this question, which is exactly along the same lines as this, and try to complete the problem. Step 1 will be to check if you meet the requirements to use the normal sampling distribution. So you multiply n times p. In this case, our n is 144, and the estimate of p is 0.24. This will give 34.56, which is a number greater than 10, so it checks out. And then you proceed to n times 1 minus p. That will be 144 multiplied by 1 minus 0.24. That will be 144 times 0.76. This is equal to 109.44, which is as well greater than 10. Since both numbers are greater than 10, we are free to go on to step 2 to find the sampling distribution of p hat. It will have the normal distribution, and we need to find the mean of p hat, and we need to find the standard error of p hat also. How do we find these two quantities? We'll use the formulas given. So the mean of p hat directly, the mean of, let's see, the mean of p hat is exactly equal to p. Since we were not given exact p, we approximate it with 0.24, which is the sample estimate. And then, once that is known, we can proceed to the standard error of p hat. That will be p 1 minus p all over n. So our p again is estimated by 0.24. 1 minus 0.24 is 0.76 divided by n. N in this case is 144, and this is equal to 0.03559. Now that we have the mean and the standard error, we can correctly conclude that the mean is 0.24 and the standard error is 0.03559. This is the sampling distribution of the sample proportion for the second example. So now that we have gone through the basics of how to find the sampling distribution of the sample proportion, we're going to move ahead and consider real-life problems that can be solved with this knowledge. So let's begin. For the first example, we're told that based on a study conducted by the Gallup organization, 76% of Americans believe that the state of moral values in the United States is getting worse. In other words, we're interested in those Americans who believe that the state of moral values in the United States is getting worse. And from the study, that is, they collected a sample of people, we found out that 76% of Americans have what, or believe that the state of moral values in the United States is getting worse. This is true in general. So the capital P here is 76%, same as 0.76. Now, we are told that suppose we obtain a simple random sample of 60 Americans, which means we are taking a sample size here of 60, and we would like to determine which believe in this sample of 60 that the state of moral values in the United States is getting worse. We would like to describe the sampling distribution of the sample proportion for Americans with this belief. We may round to 3 decimal places as needed. So what we need to do is similar to what we started off with. We need to check the conditions to use the normal distribution, and that would entail first checking what n times p is. That was 60 multiplied by 0.76, and that will give us, that will be equal to 45.6, which of course is greater than 10. Then we have n times 1 minus p. This will be 60 times 1 minus 0.76, that is 0.24, and that is equal to 14.4, which is also greater than 10. These two conditions have been met. Since they have been met, we are ready to describe the sampling distribution of the sample proportions. That will take us to step 2. In step 2, this was step 1, checking the conditions, we will need to find the mean of P at. That will be exactly equal to P. No calculations necessary, 0.76. But the standard error of P at will be the square root of P times 1 minus P all over N. So that will be the square root of 0.76, 0.76, yeah, this is not writing well, 0.76 multiplied by 1 minus 0.76 is 0.24 divided by 60. N is equal to 60, and this will give us 0.0551. Thus, we're ready to conclude that the sampling distribution of the sample proportion, P at, follows the normal distribution with a mean of 0.76 and a standard error of 0.0551. Done. Now we proceed to the next example. In a certain conservative precinct, 79% of voters are registered Republicans. So this means that in the general populace, we have 79% in this conservative precinct. Now the question is, what is the probability that in a random sample of 100 voters, meaning the sample size is 100, from this precinct, at least 68 of the voters would be registered Republicans? Let's read the question again. What is the probability? Which means I am required to find a probability that in this random sample of 100 voters, the proportion or the fraction of voters in this precinct who will be registered Republicans will be at least 68 out of the 100. So I'm to find the probability that the fraction or proportion or sample proportion is at least 68 out of 100. In mathematics, this will be translated as probability. The sample proportion will be P at is at least means equal to 68 over 100, which is 0.68. It can be equal to 0.68, but at least also means it can go above. So that will be greater than or equal to 0.68. So since I am finding a probability connected with the sampling proportion, I will need to find the sampling distribution of the sample proportion, which as it turns out, will be a normal distribution if certain conditions are met. The conditions to check will be 1, if n times p is greater than 10, that will be, in this case, 100 times 0.79, and that is 79. This is greater than 10, that checks out. Then n times 1 minus p will be 100 times 1 minus 0.79 is 0.21, and that is equal to 21. That is also greater than 10, that also checks out. So since both conditions are met, I am good to use the normal distribution to find this probability. Well, I will need then the mean of P at in this case. The mean of P at from the formula we have established earlier is always equal to P. That will be equal to 0.79 right here in the middle. And then the standard error of P at will be the square root of P times 1 minus P all over N. So this will be equal to the square root of 0.79 times 0.21. Note that the 0.21 comes from 1 minus 0.79, which is 0.21, divided by n, which is 100. And that will be equal to 0.040731. Now that I have the parameters of the sampling distribution of P at, I can now locate the value 0.68 which is a number lesser than 0.79, so should lie to the left of 0.79, and I'm interested in the area above. So this is the area of the probability I'm interested in. I'm allowed to use the normal calculator because of the approximation that is possible because it met these conditions. So I'm going to key in 0.79 and this value in my normal calculator. So here on the screen, I've keyed in the mean and the standard deviation, and I'm interested in the area above 0.68. So going back here, we go to above 0.68, and I have the value of the probability, which is 0.9965. So that will be my final answer, 0.9965. Done. This is the probability that the proportion is at least 68%.